Hi everyone, welcome to Vector Database series presented by NexGenAI. In our last video, we talked about how to create a Pinecone index and how to insert all our data inside the created index. In our today's video, we will see how to manage data inside a Pinecone index using different kind of operations. And if you guys have not subscribed my channel, then subscribe it first. And with that, let's get it started. So how we can manage the data inside a Pinecone index? So let's walk through the code and see how we can do it. So first we connect our Colab with the Google Drive. Then we need to install these libraries. The first one is Python client, Pinecone client. This will be we will be using it for creating the Pinecone client, and then python.n will be used to import the environment variables, and of course the OpenAI will be used to use some kind of embedding model from OpenAI. So here we will be needing to import some kind of environment variables like OpenAPI key, Pinecone API key, and the Pinecone environment. So these three environment variables we will be using inside our operations, inside our code. So let's import them. So describe index details. This is our first operation that we can perform on top of a Pinecone index. This tells us about what are the details of the index that is stored on the Pinecone environment or on the pod. So first we will need to make a connection with the environment or with the pod on which our index is being stored. Uh, so Pinecone dot init will be creating our connection with the port, and then Pinecone dot index property search index, it will tell us that which index to be used, which that are being stored on the pod. So we will be using property search index. So there can be multiple indexes being stored over there, so we will be using property search index from them. And yeah, so Pinecone search property search index dot describe index stats. This function will provide us all the stats of our index. So let's run it. So this is the information that we got, and it tells us that the dimensions of the vectors being stored inside the index, property search index, is 1536. Index fullness tells us whether the index is full right now, or there is a space and we can store more vectors over there or not. So right now the index is not fully filled. Yeah, so we can store more vectors embeddings inside it. And the namespace is a dictionary tells us that there are two namespaces being created. First one is duplex namespace, as I mentioned in our last video. The second one is house namespace. So in duplex namespace we have stored our total 14 vector embeddings, and in our house namespace we have stored total 13 vector embeddings. So overall we have 27 vector embeddings being stored inside our property search index. So described, for getting all the details about an index, we can use describe index stats function. Yeah. So the second operation we can perform on top of a Pinecone index is to fetch the data or to perform the get operation. So to fetch the data from a Pinecone index, we need some kind of a ID against which we want to retrieve the data point. So yeah, so property search index that we already configured, and dot fetch is the function we will be using to fetch our data from the index. And inside the IDs list, we will be providing the IDs against which we want to retrieve the data, and of course the namespace from which the data will be retrieved. So let's print it out. So fetch response yeah, consists of a couple of things. The first one is it will tell us the namespace, which is of course the host namespace, and then here comes the vector ID, and then the metadata also comes. So the vector embeddings that we stored in our last video, this is also being retrieved. So this is all the information being retrieved against 213H ID from our Pinecone index. Yeah, so the third operation is to update the some data point. So sometimes what happens, we need to update some data point that is being already stored on Pinecone index. So for that we will be using update function. Yeah. So but before updating our data point, we will be needing some vector embeddings model. We are using text embedding ADA 002 from OpenAI for create the vector embeddings of our text of our property description. So here is the function defined to get the embeddings, and yeah. So here we will be using dot update operation to update the relevant to update the required ID data. So yeah, this tells us that which index to be used, and property search index dot update operation will update the relevant or respective data point. We have mentioned the ID to be updated like 213H, and the property description here I have defined a new property description for 213 against 213H ID vector. Yeah, so we will generate the vector embeddings against this new property description. Then we will put, like here we have generated the vector embeddings by using get embedding function, and this is to be used for setting the metadata against that vector data point. So we have changed the price to 12,000 and the property type would be the house one, as earlier also it was earlier the house as well. So the namespace is house namespace. So we have defined these all the parameters that are required for updating a certain data point using dot update function. So let's run it. So our data point respective to this ID has been updated. Yeah. So in our next operation, this is the most important one for semantic search, that is used for semantic search query over Pinecone index, and yeah. So we have stored all our properties vector embeddings inside a Pinecone index that I fully described the semantic search part in our last video. So you can also watch that first, and then we can perform a query over Pinecone index operation. Yeah. So right now we will be needing we will be querying our vector database for semantic search, and this is our required query, like 4 bedrooms with ample storage and 2 bathrooms. So this is kind of a property description that we want to, against which we want to do semantic search on top of our already created property search index. So we will be creating its embeddings, and these embeddings will be stored inside the vector. Top k is equals to 3. This means we will be retrieving top 3 results. The top 3 results will be returned based on the similarity match score. So the top 3 scores, the results against the first top 3 scores will be retrieved, and of course the namespace that will be used for the semantic search is house namespace. So let's run it. So here you can see we have retrieved 3 matches, and their respective score similarity scores are 0.868, 0.854, and 0.851, and these are the IDs that are being matched. Yeah. So these are the top 3 candidates that are being matched against this our query. So if you observe these IDs data points inside our data, then you may feel that uh, these are being not fully matched. So it does not mean that this query is doesn't match with your already created vector embeddings. So the inside the vector embeddings we store these different kind of information, semantic information. It can be syntactic information. It can be the contextual information as well. So the if you read the respective descriptions that matches with this query, then you will feel that there have been discussed some kind of a thing that mentions the same thing but with different kind of a wording. Yeah. So this is the same query, but right now we have set it to five for retrieving the top five semantic searches. So here there are total five IDs being retrieved. So the last operation we will be defining is a delete operation, and it will delete the respective vector embedding, the IDs that we will mention here inside our list, and and the namespace as well. So we will be deleting a vector embedding or data point that contains this ID in this namespace. So let's delete it. Sorry, our index name is property search index. So you can see that the respective vector embeddings against the ID 216H has been deleted from our Pinecone index. Similarly, we can also delete all our and data points that is being stored within a specific namespace. Like here I have mentioned to delete all the vector embeddings that is stored inside this namespace. So this operation will be deleting all the vector embeddings that is stored in this specific namespace. Yeah, so we can also do that, but I will not be deleting it because I need to use it in our next tutorials. So this is all the basic managing data operations that you can perform on top of a Pinecone index, and I hope you guys find this useful, and you will be using these operations for your semantic search. So guys, we will be discussing more about the other vector databases like the ChromaDB. And if you guys want me to discuss any specific vector database, then let me know in comments. And till then, see you. Bye bye. Take care.